All right, we're now looking at 3 by 3 systems of equations, which is going to follow the Glencoe Notes 3-5. Make sure once again that you take a look at the vocab words throughout the textbook and are recording them in your notes. We're going to look at example 1 where we're solving the first 3 by 3 system. The method used in Glencoe is called elimination. Now, it's actually a method that I prefer as well, but sometimes 3 by 3 substitution is also a viable option. In the particular example that we're looking at, it would be very messy to do substitution because if you're noticing, all 3 of my equations have all 3 variables. Now, when using elimination, I can actually eliminate any of the 3 variables. Something that I'm noticing is that x would probably be a really easy one to eliminate because 2 of my equations actually have the same coefficient for x, okay? So the first thing I'm going to do is I'm actually going to pair 2 of my equations together, and then I'm going to pair another 2. Okay, so the first thing I'm going to do is I'm going to pair equations 1 and 2 together. Okay, when I'm looking at equations 1 and 2, I'm noticing that equation 1 has a coefficient of 1 and equation 2 has a coefficient of 2 for their x coefficients. So I'm actually going to multiply the first equation by 2, and I'm not going to multiply the second equation by anything. Okay, so when I multiply the first equation by 2, I have 2x plus 4y. Notice that I have to multiply everything by 2. Then I have 2z, and then I have 20, okay? So then the second equation, I chose not to multiply by anything because now it's going to be really easy for me to eliminate my x value, okay? To eliminate them, I'm actually going to subtract these 2 equations, and I like to make sure I know that I'm subtracting every component. That's kind of why I subconsciously circle it. 2x minus 2x, well, that goes away, that cancels out. That was the whole goal. 4y minus negative y. Well, minus and negative becomes a positive, so 4y minus negative y becomes 5y. 2z minus 3z becomes negative z. 20 minus negative 5, once again, got that double negative going, becomes 25, okay? So this is going to become my first 2 by 2 system of equations that I'm going to create, okay? So I'm going to hold on to him and I'll use him in just a moment. I'm now going to pair another 2 of my equations together. I already paired equation 1 and equation 2 together. Now I'm going to pair equation 2 with equation 3. Yes, you can pair equation 1 with 3, but for me, I like 2 and 3 together because it's going to be easy just to subtract them the way that they are naturally, okay? Actually, because they're already in alignment, I'm going to zoom in and I'm just going to do it right here, okay? I'm going to subtract the second and the third equation together. Once again, I circle my subtraction just so that I subconsciously remember I'm doing that to everything, okay? So 2x minus 2x goes away. Negative y minus negative 3y. So it's really going to be negative y plus 3y becomes 2y. 3z minus negative 5z, so that's going to become a positive 8z. And then over here, we have negative 5 minus 27 becoming negative 32, okay? So this now created our second 2 by 2 system, okay? Well, for our 2 by 2 system. So notice now my fonts are a little bit big, okay? So now I've eliminated x, and I'm back to the world of Algebra 1 where I have 2 variables. So I'm now going to pair equation 1 with equation 2, okay? So I'm actually just going to quickly rewrite that over there. Quickly. So we have 5y minus z equals 25, okay? All right, so just looking at this the way it is, it seems to me that the easiest thing to do would be to multiply the second equation by 8 because I'm going to continue to use elimination. I'm going to continue practicing it, and I'm going to eliminate z, okay? So that's going to change my second equation. 5y times 8, that's going to become 40y. That's going to become a negative 8z, and then 25 times 8, that's going to become 200. Now, I didn't think ahead. I didn't space this out very nicely, so now I'm just going to rewrite that first equation here. And so now, rather than subtracting my two equations, I can just add them together, because that's another thing you can do with elimination. So 40y plus 2y becomes 42y. Negative 8z plus 8z cancels out. Woohoo, that's what our goal was. And 200 plus negative 32 becomes 168. So now our life is looking good. We have a really easy time, and we're just going to solve for this value y. And we're going to divide by, well, I'm hoping you're guessing it, 42. And that's going to help us solve for y. So y ends up being, well, 168 divided by 42 gets me 4. Didn't think you were going to end up with such a nice number, did you? Okay. So now you're going to take that y value that you just solved for, and you're actually going to plug it into one of the smaller 2x2 systems that you created, either equation 1 or equation 2, the ones that I've circled with a red number. Okay. To me, the easier one to do would probably be the one where z does not have a coefficient, my 5y minus my z. Okay. Zoom out a little bit more. So now we have a value for y, 5 times 4 minus z equals 25. Kind of writing over my own work here. 5 times 4, well, that's 20, minus z equals 25. To solve for z, once again, we're just kind of at our home plate here. We're back to being in Algebra 1. We're going to just simply subtract 20. Negative z equals 5. Divide by negative 1. So then we're going to get z is equal to negative 5. Now here comes the best part. Remember that value x that we solved for initially? Well, now we get to plug in the two things that we just solved for to find what our value for x is. So now we're going to go back to one of our original equations and plug those in to solve for x. I'm going to choose the first equation. It looks to be the easiest. X plus 2 times our value for y is 4. Plus our value for z is negative 5 equals 10. So we have x plus 2 times 4 is 8, minus 5 equals 10. I'm going off my own notes here if you can't tell. So then we have x and 8 minus 5, that's going to be a positive 3 equals 10. Subtract 3 from both sides and ta-da! X is equal to 7. Notice that we have all three of our answers, but it's our job to put them in an ordered triple. If you don't know what I'm talking about, make sure you look that definition up. Now our answer looks gorgeous. All right, we're now going to take a look at the second example in your textbook. This is going to be an example actually where we end up with infinite solutions. So once again, you can end up with one solution, many solutions, or even a no solution, which we will deal with in a second here. All right, infinite solutions. In this particular 3x3 system, I'm going to use my observation skills and notice that actually the first and the second equation look pretty similar. So I'm actually not going to take the approach that the textbook does. So the first equation, I'm noticing that all those values are actually divisible by the number 2. If I divide all those numbers by 2, I get 2x minus 3y plus 2z equals 6. In that second equation, let's see, all those numbers are divisible by 3. That's going to get me 2x, because 6x divided by 3 is 2x. Then I'm dividing negative 9 by 3, and I'm going to get negative 3y. And then I'm going to get a 2z, and guess what? 18 divided by 3 is 6. Notice how these two are the same equation. Because they're the same equations, you're going to end up with a pretty good sign that you're going to deal with in infinite solutions because they're essentially the same plane. So the next thing that we need to check is to see whether or not that third plane is actually going to intersect with this line. So I'm actually going to use this new equation that I created here. This 2x minus 3y plus 2z equals 6. And I just want to make sure that this third equation, 5x minus 8y plus 10z, somewhere in this world intersects with him, and that I don't end up with a no solution scenario here on my plate, okay? All right, so if I want to play my elimination game, just looking at him, I'm seeing that actually z probably be my best route to eliminate. So I'm going to take this equation and I'm going to multiply him by 5, okay? Because if I multiply him by 5, then I'll end up with a 10z in that first equation. So I'm going to multiply all my values by 5, and I get a negative 15y here, and I get a 10x here, okay? So notice I just thought a little bit efficiently here. So now I have my two equations lined up perfectly to eliminate versus having to rewrite them, okay? So I'm going to subtract down because I want to eliminate a value. 5x minus 10x gets me negative 5x. Negative 8y minus negative 15. So once again, now we have negative 8 plus 15, which is going to get me a positive 7y. And then the 10z minus 10z cancels out. And 20 minus 30 gets me negative 10, which actually looks pretty gosh darn similar to the one that's in the textbook. What this just created for me is a linear equation, which means that these planes are going to intersect on this line, okay? And a line, if you think about it, has many solutions all across that line. And because you can draw that conclusion, you get to say there are infinitely many. Woohoo! All right, so we're now looking at example 3, and the textbook kind of gives it away. That's going to be a no solution here. All right, so we're going to proceed with our route of elimination. I'm going to go to eliminate a variable, and I'm going to follow the same route that the textbook takes here, where I'm going to try to eliminate A looking at my first and my second equation. So looking at my first and my second equation, they don't have anything two in common, so I don't get to just multiply one equation. So looking at 6a and 9a, a common number that both 6 and 9 go into is actually 18. So rather than dealing with ginormous numbers, yeah, I know that's a word, I'm going to try to get them to be 18. So 6 times something gets me 18. I'm going to multiply him by 3. 9 times 2 gets me 18. So that's what I'm going to multiply these equations by. So the first one gets multiplied by 3, giving me 18a. I'm going to get a 36b. And negative 8 times 3, that's going to get me a negative 24c. And 24 times 3, oh boy, that's going to get me 72. Looking at the second equation where I go to multiply by 2, I get my 18a like I wanted. 18 times 2, well, that's going to be 36. Maybe you're starting to see what's going to happen. And then we're going to get a negative 24c because we multiply by 2. Now, the thing that's going to be different is 30 times 2 gets me 60. So if we're looking at this logically, notice how in our equations the left-hand side all ended up the same. Can the left-hand side of an equation equal two different numbers? Logically, that's not going to happen. But if you're not seeing that yet, just subtract our two equations and notice 18a minus 18a, that's 0. 36b minus 36b, that's 0. Negative 24c minus negative 24c, that's 0 also. So my left-hand side ends up being 0. And 72 minus 60 equals 12. In this world, in this lifetime, will 0 ever equal 12? No way, Jose. There's no solution. Those are some of Miss Rudolph's favorite problems. All right, we're on our last example for this learning target, and it deals with a real-world problem. So the way I'm actually going to have us do this is I'm going to read the problem out loud, and I'm going to help you set out your system of equations, and then I'm going to have you solve it on your own. And then you can check your answer with the one provided in the textbook. So please make sure you have your textbook open. The other reason I need your textbook to be open is because I forgot to put the chart that is in this real-world problem on the notes, actually. Okay? So let's read it out loud together. Andrew Chang has $15,000 that he wants to invest in certificates of deposits, aka CDs. For tax purposes, he wants his total interest per year to be $800. He wants to put $1,000 more in a 2-year CD than in a 1-year CD and invest the rest in a 3-year CD. How much should Mr. Chang, Mr. Change, invest in each type of CD? All right, a few giveaways. We need some variables here. And I've been given a 1-year CD, a 2-year CD, and a 3-year CD. But the question's asking me for how much, aka how much money should he invest. That's why we're actually going to let our variable A be the money put towards a 1-year CD. We're going to let B be the money put towards a 2-year CD. And we're going to let C equal the money towards a 3-year CD. So now if we're starting to go back, okay, we have what our variables represent. We're going to look at our equation, see if they gave us any inequalities, any equations. So the very first sentence says he has $15,000 he wants to invest in these certificates of deposit. So that's the total amount of money he wants to invest, $15,000, okay? And that $15,000 is actually going to be equal to the total of money spent on each of the 3 types of CD. That's why we're going to add A, B, and C together, because we're going to add up all the money for each of those CDs, and we want it to equal $15,000, okay? Another piece of information that's necessary is a table, like I said, but in the second sentence it says, for tax purposes, he wants his total interest per year to be $800. So once again, we want the total to be $800, but when calculating interest rates, it's going to be per the amount of money of a CD, okay? So you're going to take those percents. So for A, it says we have a 3.4% rate. We're going to convert it to decimals, which means move it over 2 spots. That's why our rate for him is actually going to be 0.034. So we're going to have 0.034 times our A, because that's going to be the interest times the amount of money for A, or my 1-year CD. For B, his is a 5% interest rate. That's why it's going to be 0.05 times B. And for C, according to our textbook, our 3-year CD has an interest rate of 6%, which will be 0.06C. Oops, I kind of ran into my equal sign here. That's okay. All right, the last piece of information I have yet to use is probably the most confusing sentence. He wants to put $1,000 more in a 2-year CD than in a 1-year CD, okay? And then he's going to put the rest towards a 3-year CD here, okay? So we're really focusing in on the 1-year CD as well as the 2-year CD. So we're focusing in on A and B, okay? So he wants to put $1,000 more in a 2-year CD than in a 1-year CD. So what we're really going to do is take that $1,000. We're going to add it to the amount we put towards A. When we take that $1,000 and add it to whatever amount of money we're putting towards A, that's going to equal our B. Okay, so now we have our 3x3 system of equations. This is actually be one that's really ideal for substitution, so maybe try substituting this guy here into one of our first 2 equations. If B is equal to that whole thing, you can plug them into any of our equations here. Give it a try. Check your work in the textbook.